believe a first-rate accumulating performed by using a perpetual range of stars, planets, and moons all playing together beautifully. At any price, there's one specific fragment of this ensemble that has stunned space specialists for a critically considerable time frame: exoplanets. Exoplanets are ordinary planets that exist outside our planetary framework, hid away somewhere down inside the Milky Way. You might be amazed to find that among the tremendous range of galactic objects, there are exoplanets so like Earth, so tantalizingly similar but complicated, that they might be our planet's divine dual. We plunge into the charming space of Proxima B, located simply 4.2 light-years away. The James Webb Space Telescope is worrying our adventure for an understanding of these divine secrets and techniques. Consider a second when your mind adventures across the massive vastness of our reality, the Milky Way, that is home to more than a quadrillion exoplanets. This number has 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we would not simply fill the Grand Canyon. We'd have enough to make another landmark on Earth, a Grand Canyon 2.0 that could expand for a large distance. It's typically surprising that around 20% of these superb bodies have been distinguished as Earth-like in terms of geology and air structure, meaning there may be a 1 in 5 chance of seeing a planet that's a dead ringer for hours. And the story doesn't end there. Closed within these planets, there can be another quadrillion moons, hard satellites like our moon, trapped in a gravitational dance with their parent planets. If you somehow manage to ponder tracking down another body in space that harbors life, or could do so, the universe offers a flood of chances. Now that we've spread out the material of impossible scale, it's time to introduce the master professional worker, ready to paint its complex nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central focal point displaced by customizable principal focuses, beats even the most advanced optical devices. We are not discussing any ordinary focal point. It's 6.5 meters in primary mirrors, 2.7 times greater than Hubble's. Imagine the excellent detail it could separate, even in the smallest blaze of a star billions of light-years away, and then examine the nuances of orbiting planets. What makes the James Webb Space Telescope revolutionary isn't simply its seeing power, but also its high-level technology, such as advanced sensors and spectrographs. These tools can do considerably more than just take a look at. They can analyze and channel the light marks emitted or reflected by notable objects to decipher their air conditions, harmony, thickness, or even mass. Acting as a space researcher, they can determine whether a planet has water, natural compounds, or even oxygen. The James Webb Space Telescope has the potential to answer these inquiries, lifting it from a simple observer to a scientific genius. It's not just an advance over its predecessor, Hubble. It's more like a quantum leap. If Hubble's revelations surprised you, get ready for a real celebration of radiant discoveries. Just as we extended our look across the complicated landscape of the universe, it's worth zeroing in on one specific celebrity within the divine display: Proxima B. Since its discovery in 2016, this baffling planet has stood out as a Shakespearean legend full of unpredictability and problems. Magnificent stargazers and anthropologists alike. What's the deal with all the fight? Initially, Proxima B is located in our galactic neighborhood, just 4.2 light-years from Earth. To place it in context, if you could beat the standard speed limit and travel at the speed of light, you would arrive in just over 4 years, about the same amount of time it takes for your favorite show to fall into reruns. But let's dive deeper into why this closeness is so important. We are analyzing a universe that stretches over 93 billion light-years from one end to another, so finding a planet so close and so uplifting for scientific exploration is like finding a gem in a pile the size of Mount Everest, a gem that probably holds mysteries about life itself. In the grand embroidery of the universe, Proxima B is a complex line offering us massive tips that could reconsider how we recognize habitability and existence beyond Earth. It's not just Proxima B's nearness to Earth that excites established professionals, but also the captivating signs that this planet isn't simply Earth-like, but potentially Earth 2.0. Proxima B sits conveniently in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Consider waterfalls, meandering streams, vast lakes, and possibly oceans as deep and mysterious as the Mariana Trench. However, before we start dreaming about traveling to Proxima B, we must consider a couple of its peculiarities. Leading a single day on this entrancing exoplanet lasts a surprising 11 days. Imagine first light that not only introduces a new day, but unfolds slowly, resisting giving way to afternoon, and sunsets that linger, creating brilliant hours that photographers long for. While it sounds idyllic, it also has enormous implications for its climate and habitability. How could human biorhythms adjust to the patterns of light and dark on Proxima B? Might we really need to eat 3 or 4 times as much in a single day on that planet? Might we sleep the same way on this very unusual world? The simple patterns of life, as far as we know them, could be simultaneously tantalizingly similar and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in a riddle, testing our understanding of what makes a planet livable. You might wonder how we can acquire accurate and reliable information about a world we have never visited. The James Webb Space Telescope grants all its capabilities like a massive Swiss Army knife. It's more than just a telescope. It's a complex research lab in the vacuum of space. Thanks to its modern technology, cosmologists now not only observe planets, but also examine them through a prism of scientific tools that could make CSI labs look basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these remote planets. Each element or compound in a planet's atmosphere absorbs or emits light at a particular frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of compounds essential for life, like water, natural carbon molecules, and even oxygen. Space science is not just cosmology, it's space criminal science. We don't sit idly, waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that make up those complex worlds. The Webb telescope isn't just an eye in the sky, but a highly specialized research lab, investigator, and great detective all in one. It allows us to test our hypotheses and theories about alien worlds and turn them into methods to affirm or deny them, changing our knowledge of what may exist beyond our blue dot. Right when you thought you had uncovered the most beautiful layers of this galactic onion, the story takes an unexpected turn. Much like in any science fiction thriller, scientists using the James Webb Space Telescope received something surprising from Proxima B. A signal so amazing that it spread throughout the academic halls and social media, named as a potential technosignature. It was an electromagnetic discharge so complex and intricately designed that it could imply the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the height of a discovery that promised to reshape our view of reality. Could the signal be the actual evidence that we aren't alone in the universe? And just as quickly as it appeared, the signal disappeared without repeating, leaving behind not just a beautiful silence, but also a maze of unanswered questions and effervescing hypotheses. Was it really a transient cosmic anomaly, a random event of infinite arrangement, or something else intentional? A coded message? Or maybe a signal of extraterrestrial intelligence? The Solitary project cast a sad remnant of mystery over Proxima B, sparking wild discussion and speculation. Was it just a passing oddity? Or is it part of a much larger story, more puzzling than we can imagine? But wait, the story of our cosmic exploration is far from over. The ink has not yet dried, and new chapters are still being written. This time, it's not just conventional professionals, but Harvard researchers, who are leading a shift in perspective as we continue the quest for extraterrestrial life. They're not satisfied with just analyzing the signals and anomalies we've discussed so far. They are upping the ante by turning the James Webb Space Telescope into a kind of massive night vision telescope. They plan to look for artificial light sources in both the dark and illuminated areas of remote worlds. We're looking at remarkable possibilities, such as the chance of detecting artificial versions of cities glowing in the dark like super SPS. Imagine seeing the glowing light emissions. It could be a city buzzing with the presence of an advanced human civilization, transmitting its glow into the vast, infinite oceans. As we continue to unravel the mysteries of the universe, the hunt for extraterrestrial life takes on new dimensions. Beyond the immediate interest in Proxima B, our grand pursuit digs deeper into the vast new areas of space. This pursuit is driven by both technological advancements and a deep desire to understand our place in the universe. Advances in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Tools like the James Webb Space Telescope, biosignatures, and ground-based observatories have expanded our ability to locate and study these distant worlds. One particularly captivating area of study is the search for biosignatures, signs of life. These signs could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, could suggest biological processes. The JWST's capabilities extend beyond basic discovery. Its advanced instruments can measure the atmospheric composition of exoplanets with remarkable precision. By analyzing starlight that filters through an exoplanet's atmosphere, scientists can identify chemical markers that could indicate the presence of life.